Welcome to AI Frontiers, where we explore cutting-edge research that's quietly revolutionizing our world. Today we're diving into computational linguistics, the fascinating field of teaching machines to understand human language. We'll examine 13 breakthrough papers published on June 7, 2025, covering everything from medical AI assistants to revolutionary neural architecture innovations. These aren't just academic exercises, they're building the foundation for tomorrow's AI conversations that will reshape how we interact with technology in healthcare, legal services, and beyond. Picture this scenario. It's midnight, and you're having a conversation about a persistent cough, not in a sterile waiting room after hours of waiting, but from your couch with an AI assistant that understands medical terminology better than most humans. This AI doesn't provide generic advice. Instead, it remembers your previous symptoms, asks intelligent follow-up questions, and guides you toward the appropriate level of care. This isn't science fiction anymore. It's happening right now, powered by the computational linguistics breakthroughs we're exploring today. These systems are transforming healthcare accessibility and patient communication. We're living through the golden age of language AI. Every time you ask Siri a question, Google translates a web page, or ChatGPT helps you write an email. You're experiencing decades of computational linguistics research in action. But we're just scratching the surface. Today's research reveals that scientists are moving beyond systems that simply process text toward creating AI that truly understands context, maintains coherent conversations across multiple sessions, and expresses uncertainty when appropriate. These advances are building the foundation for AI systems in healthcare, legal services, and therapeutic applications. Think of computational linguistics as teaching bridges to have conversations with the cars driving across them. If traditional computer science is like building a bridge with precise engineering calculations, computational linguistics teaches that bridge to communicate. This field sits at the intersection of linguistics, computer science, and cognitive psychology. Linguists contribute theories about language rules and patterns. Computer scientists provide the algorithms that process millions of words per second. Psychologists offer insights into how humans actually understand and produce language. When combined, these perspectives create systems that grasp deeper meanings and intentions behind human communication. The first major theme emerging from these papers is the specialization revolution. Researchers are moving away from one-size-fits-all language models towards systems designed for specific domains. Think of the difference between a general practitioner and a specialist surgeon. While general language models provide decent advice about many topics, specialized systems like the CPath Healthcare AI developed by Chi and colleagues can engage in nuanced, context-aware dialogue, specifically tailored for medical conversations. These specialized systems consistently outperform general models in their respective domains, providing more accurate and contextually appropriate responses. The second theme involves architectural innovation, fundamentally reimagining how these systems work. Imagine architects discovering how to build skyscrapers that are just as tall and strong as current ones, but use half the materials and energy. That's what researchers are achieving with retentive networks, which solve computational bottlenecks that plague traditional language models. These networks maintain the same understanding capabilities while processing text in linear time, instead of exponential growth. This breakthrough could democratize access to advanced language AI by making sophisticated systems affordable for smaller organizations and individual developers. The third theme centers on detection and trust, developing forensic science for the AI age. As AI-generated text becomes increasingly sophisticated, we need better methods to identify it and assess its quality. Researchers discovered that detection systems working well on general text fail dramatically when applied to specialized domains like medical or legal documents. This isn't just a technical glitch, it's a fundamental mathematical property related to how different types of text are distributed. The solutions developed provide principled frameworks for understanding why domain adaptation is challenging and how to address it systematically. 4 revolutionary discoveries are reshaping our understanding of language AI capabilities. First, retentive networks enable affordable processing of long-form text, solving the exponential cost problem of traditional attention mechanisms. Second, domain-specific detection requires mathematical rethinking, as researchers discovered fundamental distribution differences between text types. Third, multi-session therapeutic AI can maintain coherent relationships over time, tracking client progress and adapting strategies based on long-term patterns. Fourth, uncertainty quantification allows systems to provide probability distributions rather than single predictions, expressing confidence levels crucial for high-stakes applications. Today's featured paper presents CPath, a sophisticated healthcare AI system developed by Shi and colleagues that exemplifies the transformative potential of specialized conversational AI. This system addresses a fundamental healthcare communication problem. Patients often don't know where to seek care or how to describe symptoms effectively, while healthcare providers are overwhelmed with routine inquiries. Built on the Llama 3 architecture, CPath serves as a bridge between patients and the complex healthcare system. Rather than replacing human healthcare providers, it enhances accessibility and communication, helping patients navigate healthcare decisions more effectively. CPath's technical innovation involves a three-stage learning process similar to teaching a medical translator. Stage 1 involves absorbing medical knowledge from clinical databases, ensuring accurate understanding of medical facts. Stage 2 focuses on learning natural health conversation patterns, enabling the system to communicate in everyday language patients can understand. Stage 3 incorporates clinical summary structures, helping the system understand how medical information is professionally organized. The researchers developed a GPT-based data augmentation framework that transforms technical medical language into natural conversations, while sophisticated conversation history management maintains coherent dialogue across multiple sessions. What makes CPath particularly significant is its human-centered design approach. The researchers recognize that effective healthcare AI isn't just about medical accuracy, it's about communication styles, cultural context, and emotional aspects of health concerns. Early testing shows patients find the system helpful and trustworthy, which is crucial for healthcare applications. By addressing these human factors alongside technical challenges, CPath demonstrates how AI can serve as an effective intermediary between people and complex professional systems. This approach could be applied to legal advice, financial planning, educational guidance, and countless other domains requiring expert knowledge accessibility. Looking toward the future, today's research points towards AI systems becoming truly collaborative partners in human endeavors. Imagine AI assistants that engage in sustained, meaningful relationships that adapt and evolve over time, like gardeners nurturing digital conversations. Picture reliable detection systems that can identify AI-generated content across any domain, ensuring authenticity in our information ecosystem. Envision language models that are more efficient and accessible to all organizations, not just those with massive computational resources. These advances suggest we're moving toward AI that embodies genuine understanding beyond sophisticated pattern matching, creating systems that are both powerful and transparently trustworthy. Remember that every conversation you have with an AI system in coming years will be shaped by the research we've discussed today. The medical AI that helps you understand a diagnosis, the legal assistant that explains complex documents, the educational tutor that adapts to your learning style, all will be built on foundations being laid by computational linguistics researchers right now. These 13 papers represent just a snapshot of global innovation happening in this field. The research is moving rapidly, and understanding these advances helps you participate in the conversation about our AI future, rather than simply observing it as a passive bystander. This research synthesis was created using advanced AI systems, including GPT and Claude Sonnet 4 models for analysis, Deepgram technology for TTS synthesis, and OpenAI systems for image generation. All content underwent human expert review to ensure accuracy and clarity. While we strive for comprehensive coverage, some oversights may exist in this synthesis. All original research references are provided for your further exploration. The archive preprint server papers discussed today are freely available for anyone interested in diving deeper into the technical details and methodologies behind these breakthrough discoveries. Thank you for joining us on AI Frontiers today. Subscribe for weekly research synthesis updates and explore the papers that are shaping our AI future. Join the conversation about computational linguistics and access the freely available research on the archive preprint server. Help us build the future of human AI communication by staying informed and engaged. In this podcast, we bring you the latest breakthroughs in computer science and AI, straight from archive preprint server. From neural networks to quantum computing, we simplify complex research so you can stay ahead. Whether you're a developer, researcher, or tech enthusiast, AI Frontiers keeps you informed daily. Thanks for listening. If you enjoyed this episode, subscribe for daily updates. See you tomorrow with more cutting-edge AI insights. Disclaimer: this video uses archivepreprinserver.org content under its API terms of use. AI Frontiers is not affiliated with or endorsed by archivepreprinserver.org.